Using a digital storage oscilloscope, I'm going to measure 4 outputs from the Cosmic Ray Muon Detector. The first green trace is the raw output pulse of the top Geiger-Müller tube. The yellow trace is the same pulse converted to logic. The blue is the output of the bottom Geiger-Müller tube, and the orange trace on the bottom is the coincidence output when the top and bottom pulses coincide. The output pulses of a Geiger-Müller tube are very random and are between 5 and 60 counts per minute, less with shielding. The pulse width is typically around 50 microseconds. Here I'm recording the output pulses of the top and bottom Geiger-Müller tubes. As you can see, it is very random, and it's very strange that any 2 pulses would coincide. However, when we feed the outputs of each Geiger tube into an AND gate and measure coincidence between the 2 Geiger tubes, we see that every now and again we have a coincidence. Only a particle travelling at high speed, triggering both tubes, could do this. This is our muon created from a cosmic ray.